everyone, welcome to my channel. So our weekly contest 412 last problem was count almost equal per second. Okay, so what does the question state? In this version, the number of operations that can be performed has been increased to twice. Okay, so basically the first question of this contest was count almost equal pair one. Okay, if I have also made the video for this particular question, you can see at the top of this particular video for this particular for this questions video. Okay, so now what does the question states? Okay, uh, the both the questions are same. Okay, so let me guide you through the question. It states that you are given an array nums consisting of positive integers. Can we call two integers x and y in this problem almost equal if both the integers can become equal after performing the following operation at most once, that is once or zero times. So what is the operation? The operation is you can choose either of x and y and swap any two digits within the chosen number. Okay, and you have to return the number of indices I and j in nums where I is less than j, such that nums of I and nums of j are almost equal. Okay, so see, in this particular problem, basically it is saying is 12 is there and 21 is there. Okay, so you can select any two numbers from nums of I, right? So basically if you select 12 and 21, now with but suppose this is x and this is y, so you can select any of these two numbers, x or y. Suppose I select y. Okay, and in y you can basically swap two digits. Okay, so if I swap 1 and 2, like 2 and 1, so it becomes 1 and 2. Okay, and 1 and 2 and 1 and 2 are equal, so basically they are almost equal. Okay, and similarly the output is 2, so here also it is given a note that it is allowed for an integer to have leading zeros after performing an operation. So basically, 3 is there. Okay, so basically if you swap 3 and 0, so 0 comes here. So 3 is equal to 0 3, which 0 3 is equal to 3 only. Okay, that's why. So the answer is 2. Okay, in this way. Now, the second question, that this is also the same question. The only difference you can perform at most two swaps. Okay, like earlier we are performing 0 or 1 swap. Now you can perform 0, 1 or 2 swaps. Okay, so let me first guide you through the code because you have to make simple changes in this code only to solve the second problem. Okay, so in the first, basically in at most one swap, what we were doing is, see, here I have taken this nums n is equal to num size. Okay, I have taken two loops. So basically I have taken for loop. Okay, and each time I will compare two numbers. Okay, so suppose I is pointing to 3 and j is pointing to 12. Okay, for this j loop. After this, I will basically convert both of them to string. Why I'm converting into the string? Because see, we have to perform swap operations. So basically, it would be easier for us if we convert it into the string. After that, we can basically swap the indexes of this particular string. Okay, that's why I'm saying. And I'm sending these two values s and t to is equal function. Okay, is equal function will basically check they are almost equal or not. If they are, it will return 1. Otherwise, it will return 0. Okay, if they are 1, so basically, we will increase the count variable and the return count. Okay. Firstly, it will compare 3 and 12. No, they are not equal, so it will return 0. So nothing will happen. 3 and 30. Yes, they will be almost equal, so it will return 1, and count value would be 1. Similarly, 317, 321. Okay, it will return 0. 12, 30, 12, 17, 12. These both will return 0, but 12 and 21. If we swap 2 and 1, it becomes 12. Okay, so this will be equal. So it will return 1, and the count value will be incremented by 1. Okay, in this way. And so basically in this particular array, only two values were there which were almost equal. Okay, so let me now guide you through this is equal code. Okay, so it is of boolean, it will return either 1 or 2. Okay, first of all I will check whether s or equal to t or not. See, you can perform the operation 0 and 1 times. So 0 times means you don't have to perform the operation, and when it will be 0, when s and t are equal. Okay, that only then. Otherwise, what I will do is, see, it will be easier for us to compare the two strings if their length is equal. Okay, see, suppose here our string is 3, right? S string is 3 and T string is 30. So if I perform the swap operation on 30, it becomes 0 and 3. But if I compare 3 and 0, 3 in a string, they are not equal. Integer, yes, 0, 3 and 0, 3 are equal, but in a string they are not equal. Okay, so what I will do is first I will make both the strings of equal size. Now, in order to make these two strings equal, and I do basically don't have to change the integer value also. So basically, what I can do is I can in front of 3 I can add 0. Okay, so if s dot size is greater than t dot size, then I will in the t I will increment I will add 0 in the front of the t. Otherwise, in the s I will add 0 in the front. Okay. Now basically 3 has become 0 and 3. Okay. So suppose now we are here. So what I am doing is, see, you can choose any of the string s or t. You can perform, you can, so basically I have chosen 3, and on the on sorry t, and on this t string I will perform the swap operation, right? And if the swap, and after performing the swap I will check whether s is equal to t, right? I will compare it with s, and if it is, then I will simply return 1. Otherwise I will again swap them. So basically, make them into their original form. Okay. Suppose 3, 0, 3 and 1, 2 are there. Okay. So I will perform a swap. So it becomes 2 and 1. Okay. And 0, 3 is not equal to 2 and 1. So basically, I will uh, basically z swap this particular string. So it becomes 1 and 2 again. Okay. That's in this way. So only this is the code. If I walk you through the code, suppose this is our array 3, 12, and 30. Okay. Initially, our I is pointing to 3 and j is pointing to 12. I am talking about this particular loop here. Okay. So now what I will do is 3 and 12. So I s will be 0, 3. Okay, I have added 0 because I have to make this both the strings equal. T will be 12. Now I will perform the swap operation, so it becomes 21. I will compare 21 with 0, 3. No, they are not equal. Then I will again swap them, so it becomes its original shape. Okay. Now, so basically I have chosen 12. Okay, the T string, and I was using this inner loop on this particular string. Okay, this loop. Basically this loop. Okay. This loop here, it is working on this here. I is pointing to 1, j is pointing to 2. I have swapped them. Okay, so basically now jf has ended. Okay, so basically we are out of the swap, and I out of this particular loop that was running on the string, and it will simply return 0. Okay, so when it returns 0, then j will be incremented. Okay, so now j will be pointing to 30. So now our s becomes 0, 3, t becomes 30, and on this particular t string, I will again use two loops. Okay, and again I will swap them, so it becomes 0, 3. If they are equal, then it will return 1. Okay, so in this way it will work. Okay, hope you have understood this solution. Okay, now coming to this particular second problem, we have to perform a swap at most twice. Okay, so what I can do is, earlier I was performing one swap. So basically if I have to perform two swap in this particular question, so what I will do is, basically here I am doing the check, and after this I can simply copy paste this particular code. Okay, this, and here I have to basically rename this I and j variables because we have earlier used I and j. Okay, now let me show you the code. Here, see, this is basically the same loop that we are using earlier. Just I have replaced I with k and j with l. Okay, and now see, earlier we were performing one swap. Now this will perform two swap, and at the same time it will check s and t are equal or not, right? And if I show you this particular example for this, okay, so suppose I take an example 1, 2, 3, 4. Okay, 1, 2, 3, and 4. Okay, this is our array, and 4, 3, 2, 1. Okay, so our array is this, and there are two values, and we can perform two swaps. Okay, so again what I will do, again the same code was there. This is a, and this is I, and this is j. Okay, the string lengths are equal, so s would be 1, 2, 3, 4. Okay, so 1, 2, 3, and 4, and our t would be 4 3 2 1. Okay, 4 3 2 1. Okay, currently I am here. Okay, I have converted into the string. Okay, where I is pointing to I is pointing uh, I is pointing to here, J is pointing to here. Okay, then I have converted into the string. This both the strings are of same length, so I am not adding any zeros in the front. Okay, now I can choose. You can choose any of the string S or T and perform the swap operation on them. Okay, and then you can simply compare it with S. Okay, so suppose I choose T, I will perform the swap operation on this particular string. Okay, and at the same time I will also check whether it becomes equal or not. Okay, so now currently I is pointing here and J is pointing here. Okay, I will perform a swap. So basically it becomes 4 and 3, 3 and 4. Okay, after this I will come to the second loop. Okay, so second loop would be K and L. Okay, so K, like after swapping, that it becomes 3, 4, 2 and 1. Okay, now our K is pointing here and this L is pointing here. If I swap them, nothing will happen because it will become 4 3 2 1 and it is not equal to 1 2 3 4. Okay, so nothing will happen. Then I will swap 3 and 2. So 3 2 4 3 1 would be the our new string. Again it is not equal to 1 2 3 4. Okay, then I will swap 3 and basically 1. So 1 4 2 3. Again it won't work. Okay, in this way. So in this particular swap will only work when I will come here. Okay, so basically j for j is equal to 3 it will not work, for j is equal to 2 it will not work, for j is equal to basically this particular third index it will work. Okay, so if I swap them, now the string becomes 1 3 2 4. Okay, basically for the first loop. So basically currently I am here. Okay, I have performed the swap till here. I have checked s is equal to 2. No, they are not. So I will perform this now inner loop. Okay, so inner loop again will work the same way as our earlier loop was performing. So I will point here, j will point here. They will swap. So 3 1 2 4 is equal to 1 2 3 4. No, it is not. Similarly, j will come here. So 2 2 3 1 4. No, now j will come here. Okay, 4 1 4 3 2 1. No, it is not, so it won't work. So after that I will come here on the 3. Okay, and j will come here. Okay, because see we are reshaping, basically we are if they are not, if after step they are not equal, then we are basically rearranging them in its original, in this original position. Okay, so at one point this will be the condition where I will be pointing to 3 and j would be pointing to 2. Now we will, if we were from the swap, it becomes 1 3 1 2 3 4. Yes, they are equal. Okay, they both are equal, so we will return 1. Okay, so two loops. So see, after performing this one swap, the string was not equal, but after performing the two swap, the string becomes equal. Okay. Oh, sorry for that. Okay. So hope you have understood this concept. But now, what's the complexity of this particular solution? See, the constraints are nums dot the array size is up to 5,000. Okay. So basically 5,000 into 5,000. Okay, and then the nums of I is up to 10 to the power 7. So basically we are converting it into string, so the string size is 7 at each operation. Okay, so we are performing the operation 4 times, so the size would be 4 to the power 7. Okay, so the complexity is high. If I run it, it will be running fine. Well, yeah, if it is running fine, but if I submit it, it will probably give TLE. Okay, so yes, yes, it is giving TLE. Okay, because see, the complexity is currently 5,000 into 5,000 into 4 to the power 7. Okay, so basically we have to reduce the complexity. So now what we can do to reduce the complexity? Can we use some extra space? Okay, so in this way, you have to think. So see here, basically, here you can see that 4 to the power 7, like Okay, 7. Sorry, the complexity would be 4 to the power 7. Okay, for this particular loop, 4 to the power 7. And 4 to the power 7 is somewhat between 2000 and 3000. Okay, so that's not that big. But here, 5000 into 5000 is like we are performing a lot of times here. So, right? So, can we use some extra space? See, what we can do is here we are using two loops. So, instead of this, what we can do is basically. Uh, I basically see I am performing the brute force, right? For every string value, uh, I am performing a brute force, and basically I am finding all the possible strings that we can convert. Like suppose this was our number. Okay, if we are sending this particular number, we are basically checking all the possible cases, all the possible strings that we can make with this particular number. Okay, and it would be 4 to the power 7. Okay, now what I can do is to reduce the complexity, I can use some extra space. So I will basically take one set variable, okay, set. And what I will do is I will store all the permutation and combination that we are finding of this particular string that are right, like 1, 0, 2, 3, and after swapping 0, 1, 2, 3 is there, okay, 1, 2, 0, 3 are there. Okay, I will basically store all those strings into the into the data structure set. Okay, and now what I will do is basically instead of using this inner loop, okay, here, what I will do is I will simply return the set. Okay, and then in that particular set, I will check whether like here I have to use another map where I will store all the strings that I have traversed. Okay, so initially map will be stored 1 to 3, 1023. Okay, so let me walk you through the code that will make it much easier for you to understand. Mhm. Okay, I will comment it out. Okay, and this is our new solution. Okay, so what I will do is see, instead of using the this concept is will be the same here for that, but instead of returning one, I will take one set data structure, and I will see instead whenever I was returning one, or whenever I was performing a swap operation, instead of returning one, what I will do is, sorry, instead of performing superposition, sorry, instead of checking whether s becomes equal to t, I was returning one. Instead of this particular thing, I will basically insert that particular string into the set. Okay, that's what I will do. So here, as you can see, okay, I have to comment it out, this particular portion also. Okay, okay, this is our code. So right, the code is same as it was before. Okay, we are using these four loops. Okay, the complexity would be equal, that is 4 to the power 7. But instead of comparing and returning one, I will simply insert this particular string into the set. Okay, now basically what this operation, what this function would do is, I will send this string to this particular function, and this basically operation will find all the possible combination of this particular string and store them into the set. Okay, and after that I will return the set. Okay, so basically set, we will receive the set here. Okay, and then once I receive the set, so basically see, if you can see, I have removed the inner loop that I was using earlier, that is this particular inner loop. Okay, so what I will be doing is I will be using set here. So in the set, you can see all the permutation and combination of this particular string is there. Okay, and I will basically check uh, in the map whether this particular string is present or not. Okay, so basically what I have done is, here n is equal to nums dot size. Okay, so I have take, what I will do is, here all the string size are equal, this is not equal. Okay, so for this particular string, if I check, what I will do is I will make it to 0 to 1 3. Okay, and earlier we were sending s and t, that is two strings, into our function. Now we won't we don't have to check we don't have to compare S and T. So basically I will send only one string at a time, and I will receive all the permutation combination into the set. And here in the set, basically I will compare that in the map, the this particular value is there or not. Okay, so here this particular function is there to make every string equal. Okay, so this is of size 3 and the maximum is of size 4. Okay, so basically I will add 0 here, so it becomes 0 2 1 3. Okay, now I will use one unordered map. I will tell, like, I will let you know why I will use this, but for initially just think that we have used map, it is of a string and integer type. Okay, and now I'm traversing through the nums array. Okay, this particular array here, and string, I am converting it into the string. Okay, and basically I'm adding 0 to the string. Okay, and here I have used this unordered set. I will use this total combinations. Okay, for this particular function. This particular function will return me the total combinations, okay, of this particular string. Okay, because we have sent this string and the set. So basically in the set now there are all the combination of this particular string. Now what I will do is I will traverse through the set. Okay, and I will check whether in the set, uh, whether in the map this particular combination is present or not. So 1 2 3 1 0 2 3 is there. Initially our map is empty, so it won't do anything. And if we find, we will simply increment our answer variable with m of it. Okay, so basically in the map this set value is present, and if it is, then the count of that particular value would be added to the answer, and at the end I will return the answer. Okay, and if this function doesn't work, that is our, if initially our map is empty. Okay, and in the set there are all the combination of this particular string. So what it will do is, in the map it will store 1023. Okay, and now again we will again move it, so our set will become empty. Now I is pointing to here. Now the set will contain all the possible combination of this particular string right here. For this function will work in this particular way, and we have this all the combination of this particular string. Now what I will do is, for all the combinations, right, I will check whether any of the combination matches with this map value, that is 1023. If it matches, right, so see, two basically 2310 is there. If after performing a two step, if there is if it makes 21023, then it will solely be present in the set. Okay, and we are traversing through the set, that is we are comparing each of the value in the set with this particular value. If it matches, then basically I am incrementing our answer value with the count of that particular value. Okay, so initially the count is 1 only. So suppose if there are duplicates 1023, then again there is 123 1023, then there is 2310. So basically the in the map the count of 1023 would be 2. Okay, and when I am performing this particular operation on this particular string, so 1023, yes, it is the after performing the two swaps, 1023 would be there. So basically I will add 2 times. Okay, because 1023 is present 2 times in the nums array, so I will add it 2 times. That's why I have taken the map. Okay, and I am basically counting that how many times this particular number has appeared in the map. Okay, hope you have understood and understood it. Now let me just take this example. If I take it 1023, okay, 1023, this is our I. Okay, and our j is 2310. 2310. Okay, so basically we will send our j our I is initial I was earlier pointing to this. Okay, and map was empty, so nothing has happened. So in the map basically we have stored 1023. Okay, 1023. Sorry for this handwriting, I am not used to the whiteboard yet. Okay, so basically nothing will happen, answer will remain 0. Okay, now I will point here, and so basically our set will contain all the permutation combinations of this particular string. So if you check, like one swap would be like this. okay, like this. And when this particular swap happens, so the string becomes like set contains 2310, okay. Set also contains, like if I swap it, 1 will come here, 2 will come here, and if I swap 0 and 3, 0 would come here, 3 would come here, okay. This would be present in the set. And also 1032 is also present in the set, okay, in this way. So basically all the possible combination that would be 4 to the power 7 are present in this set, okay. Now we will return the set, and now I will iterate through this set, okay. Now I will iterate through the set and I will check whether this is present in the map or not. So is this present in the map? No, it isn't. If this value is present in the map, yes it is. And the count of this particular map, the key value, that is 1023, is 1, okay. So I will increase, I will simply add it into this answer variable, okay. So answer becomes 1, right, in this way. And why I am using this plus is equal to am of it, that is v value, right? So basically, suppose if there are two values, right? Suppose this has come, like this was our array, okay? This was our array. Suppose 1023 comes two times, okay? 1023, okay? Yes, it comes two times, okay? Then what in the map, what it will be stored like in this particular way, okay? In this particular way. Now it will, when it will check, so it will basically add 2 in place of 1, because see, this particular thing is equal to this also and this also. That's why, okay, that's why I've used map, okay. Oh, now if I run it, hope you have understood the concept here. Now if I run it, okay, yes, it is running fine. And now if I submit it, yes, it is accepted. Okay. Hope you have understood the problem, guys. If you understood the problem, give me a thumbs up and subscribe to the channel. If you have any query related to this particular question, you can ask into the comments. I will definitely give the answers. Okay. So thank you. See you in the next video. Till then, goodbye.